Alright, we're going to be evaluating limits analytically. So let's get started. We've got the limit of, let's say, x approaches 1, and we're going to have x squared minus 1 over x minus 1. So the first thing we're going to do is we're going to plug a 1 directly in. Okay, doing the direct substitution, and let's see what we get. Well, if I were to plug 1 directly in, we'd end up with 1 squared, which is 1 minus 1, over 1 minus 1, and yeah, that's not good. We get 0 over 0. So what we want to try to do here is see if we can factor some things out and cancel and get a new function. Alright, so let's just do that. So I'm going to rewrite the limit as x approaches 1. And so I can factor the numerator into x minus 1 times x plus 1, and it's all over x minus 1. Okay. Well, as you can see, we're going to be able to, it looks like we can cancel an x minus 1 out of the top and an x minus 1 out of the bottom, and now we're going to end up with a new function. So let me rewrite this so we have the limit as x approaches 1 of x plus 1. So now we can do the direct substitution, plugging 1 directly in for x, and it turns out that our limit is equal to 2. So even though we have a different function here, right, it's just disagreeing at the point where x is equal to 1. So this is still equal to 2. So if we end up getting a 0 over 0, there's an indication that there's a hole in the graph at 1. And so what you want to do is you want to factor and cancel. Okay, factor and cancel in this particular case. Alright, we are evaluating limits analytically, and let's take a look at a problem here that was similar to the last one. So we have the limit as x approaches negative 1 of x squared minus 1 over x plus 1. So the only difference here, we have a plus in the bottom and we're approaching negative 1. So if I were to plug negative 1 into the numerator, we would end up with negative 1 squared minus 1 over negative 1 plus 1, and that ends up becoming 0 in the numerator, 0 in the denominator, and yeah, that's not good. So what we need to do when you end up with something like that and it looks something similar to this, what we need to do is we need to factor and then try to cancel out and get a new function. So I'm going to rewrite our limit as x approaches negative 1, factoring the numerator, we get x minus 1 times x plus 1 and that's all over x plus 1. So as you can see here, we're going to be able to cancel out. We have an x plus 1 in the numerator and x plus 1 in the denominator, and so we can cancel that out and get get a new function. So I'm going to end up just rewriting this. So we get the limit as x approaches -1, and we have x minus 1 now, so we have a new function. However, our domains have changed. Okay. If you were to take -1 now and to plug it into the direct substitution, plugging it in, we end up with -1 minus 1 is equal to -2. So if we're to go back up here into our original, we could say that our limit is -2. Alright, moving right along. Let's take a look at this one here. We've got the limit of x approaching -1. Again, alright, we have 2x squared minus x and minus 3. And that's going to be all over x plus 1. So if I were to do the direct substitution and plug -1 directly in, you're going to end up seeing that we're going to end up getting -1 plus 1 in the bottom, which is 0. Okay, and probably if we plug -1 in the top, we're probably going to get 0 also. Let's just do that quickly here. -1 squared is 1, 2 times 1 is 2. We have a minus, so if we were to plug -1 into here, we'd get a plus 1. So let's see, that'd be 2 plus 1 is 3, and yes, 3 minus 3 is 0. So we end up with a 0 over 0, which means that we need to try to factor and cancel terms out. Okay, so let's do that. I'm going to rewrite the limit as x approaches -1. Now let's see, the numerator factors. We've got a 2x. Okay, we'll start with that right there. Two numbers multiplied together gives us -3, and when we add them, let's see, we're gonna okay, I think this is going to end up being a -3 here and a +1 here. So if you were to multiply this out, we should get 2x squared minus x minus 3. Right, 2x squared plus 2x minus 3x is a -x, and -3 times 1 is -3. Okay, caught up in the intermediate algebra. Even though that's what most students struggle with in calculus, is just the intermediate algebra steps. If you take -1 now, first we got to do some canceling. So as you can see, we have an x plus 1 here and an x plus 1 down in the denominator, so we can cancel this out and rewrite this limit now. So I'm going to rewrite the limit as a limit as x approaches -1, and I'm going to rewrite our new function now as 2x minus 3. So we do the direct substitution, plugging -1 directly in. 2 times -1 minus 3 is equal to -5. So we could say that our limit, our original limit, is equal to -5. Cool. Okay, so we're going to look at a little bit maybe more difficult problem here. This time this is going to be focusing on the difference of two cubes. So if we were to do the direct substitution here, plugging 2 directly in, as you can see, we would get 2 cubed is 8, and 8 minus 8 is 0. We'd get 0 in the numerator, and if I plug 2 into the denominator here, you'd get 2 minus 2 is 0. So once again, we're getting 0 over 0. So we need to factor and then cancel out terms. But the question is, how do you factor x cubed minus 8? Well, you might know how to do that, but for those who don't, let me go ahead and just work that out. So this x cubed minus 8 can actually be rewritten as x cubed minus 2 cubed over x minus 2. I'll just rewrite the limit here, notation. Okay, so this is the difference of 2 cubes in the numerator, and this can be rewritten, or I should say we're going to factor this. So we're going to end up writing, first we'll write x minus 2, put a parentheses around it, and then we're going to say x squared, and just take the opposite of whatever this sign is, plus 2x, and then you square the 2. So whatever the number is here, we're going to square it. So this becomes a 4. So if this were an x cubed plus 2 cubed, if this were a plus right here, then we would end up putting a plus here and a minus here. But this sign here is going to always be a plus. Right? And I'm going to go ahead and rewrite the limit as x approaches 2. Okay? And I guess I better not leave out the denominator here. So now as you can see, we can cancel out an x minus 2 in the numerator and an x minus 2 down here in the denominator, and now we can go ahead and rewrite the problem and then do our direct substitution. So we have the limit as x approaches 2, rewriting just the numerator, x squared plus 2x and plus 4 is equal to, so now we do the direct substitution, plugging 2 directly in. You get 2 squared plus 2 times 2 plus 4, and our final answer should be 12. Right? 2 times 2 is 4, 4 plus 4 is 8, and 8 plus 4 is 12. So this is, go back up here to the original problem, right? So our limit is equal to 12. That wasn't so bad. I've got a few minutes here, or a minute or so. Let me write down the formulas again. So x cubed minus a cubed, if we were to factor this, this factors to x minus a times x squared plus ax plus a squared. Okay, this is the problem that we worked on. But if you had x cubed plus a cubed, we end up with x plus a times x squared minus ax plus a squared. Alright, we'll work another one, and this next one we're going to use the sum of 2 cubes. Okay. Alright, let's look at this one here. We got the limit as x approaches negative 2 of x cubed plus 8 over x plus 2. So if I were to plug negative 2 directly into this, we'd get negative 2 cubed would become a negative 8, and negative 8 plus 8 is 0, so we get 0 in the numerator. Plugging negative 2 into the denominator, we end up with 0. So we get 0, 0, which means that we might want to try to factor and cancel some terms out here. And this happens to be the sum of 2 cubes. So let me just rewrite this as the limit as x approaches negative 2 of x cubed plus 2 cubed over x plus 2. So in the previous problem I gave you some formulas on how to factor the sum and the difference of two cubes. So let's hope that you remembered that. Wrote it down or something. Okay, so we can factor the numerator as x plus 2, right? So we just carry this plus down. And then we rewrite. We say x squared, and you take the opposite of whatever this sign is. We're going to put a minus. And then we say 2x, and then we square this minus 2 right here, squared. So that becomes a 4. And that's all over x plus 2. So now what we can do is do a little canceling, right? So we can cancel these guys out because x plus 2 over x plus 2, right? And it's just going to be 1. So we just cancel that out. Okay. And then I'm going to rewrite the limit as x approaches negative 2 of x squared minus 2x plus 4. And then we do the direct substitution. So we have minus 2 squared minus 2 times, right, the negative 2 and then plus 4. And we do the arithmetic now. Let's see, we get this particular one here, we're going to get 4, negative and a negative becomes, alright, so we get 4 plus 4 plus 4, which is going to be equal to 12. So that's like the same as the last problem. Okay, so the original limit that we was originally working on here, oh, went too far on that, is equal to 12. Alright, here's another one here. We got the limit as x approaches 3 of 3 minus x over x squared minus 9. So when we plug the 3 in, we get 3 minus 3 is 0 in the numerator, and we plug 3 in the denominator, we get 3 squared is 9, and 9 minus 9 is 0. So once again we get 0 over 0. So what we're going to need to do is we're going to need to factor and cancel some terms out if we can. So I'm going to rewrite this. And we have 3 minus x over x minus 3 times x plus 3. So as you see in the denominator here, we have this difference of two squares, right? Because that's a 2 there. Well, we have an x minus 3 and an x plus 3, but it doesn't seem like we have either one of those in the top. This is a 3 minus x. But what I'm going to do is I'm going to factor this negative out. Okay, I'm going to factor the negative out. Let's do a little side work over here. So if I were to factor this negative out, I'm going to say I'm going to factor out a negative 1. This becomes minus 3 plus x. So this is like a trick here. So in other words, if I were to distribute this negative 1 back inside, you would have a 3 and then minus x, just like we have up here in the numerator. But factoring that negative 1 out, right, then we're going to end up with, if I was to rewrite this, this is x minus 3. And a little negative out in front there. Okay, well, we do have an x minus 3 in the denominator. Okay, so we're going to be good to go. Alright, so I'm going to rewrite this as the limit as x approaches 3 over x minus 3 times x plus 3. Okay, now we can cancel some stuff out. We have an x minus 3 in the numerator and x minus 3 in the denominator, so we can cancel those out. Now I'm going to rewrite this again. So this is the limit as x approaches 3 of, and I'm going to put this negative here, I'm just going to bring it out front, over x plus 3. Now we can do our direct substitution, plugging 3 directly in. And of course that simplifies down to negative 1 over 6. So we can go back up into the top here, and where we started out with our original limit, we can say that this is equal to negative 1/6. Okay. Okay. What do we got going on here? We got the limit as x approaches negative 3 of, let's say, x squared plus x minus 6, and it's all going to be over x squared minus 9. Okay, so the idea is do direct substitution first and see what you get. So if we were to plug negative 3 into the top up here, we'd get negative 3 squared, which is going to be 9. Plugging negative 3 into x here, so that's going to end up being a negative 3. So we're going to have 9 minus 3 minus 6. Well, minus 3 minus 6 is going to be a negative 9. Or we'd say 9 minus 9 is 0 on the top. And if we plug negative 3 into the denominator, you'd have 0. So 0 over 0. So that means that we need to try to factor and then cancel some terms out. So let's do that. So we're going to always rewrite the limit as x approaches negative 3. Okay, so I'm going to factor the numerator, and this should factor to, this is how I always do this. I start out like that right there. Okay, two numbers multiply together gives us negative 6, and then when we add them we get a positive 1. So how about we start with a 2 here and a 3 here. 2 times 3 is 6, but we need to get a negative here. So how about we say a minus 2 and a plus 3. I think that'll work out. Now we have a sum of or we have the difference of 2 squares, so this becomes x minus 3 and x plus 3. So we have an x plus 3 in the numerator and x plus 3 in the denominator. We will be able to just cancel those guys out. Now I'm going to rewrite this limit. So we have the limit as x approaches negative 3. We have x minus 2 in the numerator and x minus 3 in the denominator. So now I'm going to go ahead and do the direct substitution, plugging negative 3 directly in. Alright. And we end up with, actually, I like to write it actually below here. So we have negative 5 over negative 6. And of course we have a negative over a negative, so that's going to cancel out. And our final answer is going to be a positive 5/6. So we can come up here now and say that our original limit is equal to 5/6. Easy enough. Evaluating limits analytically. So I'm working out examples, and it's more likely these are examples that you'll probably see on a test or in your homework. Oh, we forgot to say what we need, what we're going to here. We're going to 3. So we got the limit as x approaches 3 of x squared minus x minus 6 over x squared minus 5x plus 6. So we do the direct substitution, plugging 3 directly in the numerator and the denominator, and if we get 0 over 0, then we probably need to do some factoring and canceling out. So if I were to plug 3 in the numerator, we get 3 squared is 9, and 9 minus 3 is 6, and 6 minus 6 is 0. So we end up with 0 in the denominator. What about down here, or I'm sorry, in the numerator? Down here in the denominator, we got 3 squared is 9, and 5 times 3 is 15, and then we end up with 9 minus 15 is going to be a negative 6, and a negative 6 plus 6 is 0. So we get 0 over 0. Okay, so let's do some factoring if we can. So I'm going to rewrite. Okay, so this is going to factor to x plus 2 times x minus 3. And then the denominator is going to factor to x minus 2 times x minus 3. And as you can see here, we have an x minus 3 in the numerator and an x minus 3 in the denominator, so those are going to cancel out. And now we're going to get to rewrite. So we have the limit as x approaches 3 of x plus 2 over x minus 2. So now we can do the direct substitution. Plugging 3 in, and we end up with 5 over 1, which is just 5. So we can go up to our original limit up here and say that as x approaches 3 of this function here, right, we're going to be getting 5. Okay. Okay, quiz time. It's quiz time. We got the limit as x approaches, what's x going to approach? 2? 2 sounds good. Of 4x cubed minus 32 over 3x minus 6. So there's your problem, and you try to get the answer. Okay, so pause the video. Pause it now. Do it. Okay. Alright, here's the answer. The answer is 16. So you try to do what you got to do here and get 16 based on what I have taught you in the past. Now, there is a little twist to this problem, but twists are good. Alright, let's move on. I want to now move on to something else. Well, actually, we're still solving limits analytically. We have the limit as x approaches 0. We got an exponential function here, e to the 2x minus 1 over e to the x minus 1. Okay, hopefully you know what e is at this point in your math career. It's just a constant like pi. It's a transcendental number. I think it's like 2.71, yada yada yada. Okay, if I took 0 and I were to plug it in, do the direct substitution, 2 times 0 is 0, and a number raised to the 0 power is 1, right? And 1 minus 1 is 0, so we get 0 in the numerator, and then if I plug 0 in for x here, we're going to end up with e to the 0 is 1, and 1 minus 1 is 0, so we get 0 over 0. So what in the world are we going to have to do here? Well, that's where I come in. I'm going to rewrite this guy. Now this should look familiar. Familiar to what we've been doing. We have the difference here of 2 squares. The difference of 2 squares. So we can factor the numerator e to the x minus 1 times e to the x plus 1. Alright, so that guy factors out to that, and we have e to the x minus 1 down here in the denominator. So as you can see here, we have e to the x minus 1, e to the x minus 1, so we can cancel those out and then rewrite this limit. So we have the limit as x approaches 0, and we have e to the x plus 1. So now we can do the direct substitution, plugging 0 directly in. We get e to the 0 plus 1. Now a number raised to the 0 is just 1. And so we end up getting our answer to be 2. So that means that we can go up here into our original and say that this limit is equal to 2. Cool. So I'm going to write down another problem here, and this is going to be a quiz problem. So you should be able to get this no problem at all. This should be easy. Okay, so pause the video and come back to get the answer. See if you have the same answer as I do. Okay, so we got a new kind of problem now coming up. We're still evaluating limits analytically though. But you're going to need to know another technique. It's not too bad. Okay. Ugh. If I were to plug 0 directly in, doing the direct substitution, you get the square root of 5 minus square root of 5, so we get 0 in the numerator, and of course you plug 0 in for x down here. We got 0 in the denominator, so we get 0 over 0. So this time, okay, so we can't factor like we've done in the previous problems and cancel some terms out. So we're going to do something else. We're going to multiply the numerator by what's called the conjugate. So the conjugate of this guy here is x plus 5. Because we have a minus, we're going to put a plus. The square root of 5. And that's all over. Now what we do in the top, we got to do in the bottom. Okay. If I were to multiply this stuff out in the numerator, you get the square root of x plus 5 times the square root of x plus 5, and you're just left with x plus 5. And of course, because we have a minus and a plus, we're foiling this: first, outer, inner, last. Okay? But because we have a minus and a plus, the inside stuff's going to cancel out. And so we're going to be left with a negative square root of 5 times a positive square root of 5. And that's just going to leave us with a minus 5. And then I'm just going to rewrite the bottom, because that's all we can really do here. Plus the square root of 5. Trying to be as neat as I can. It's hard to write on this tablet. And now we can simplify this down some more, and we see that the 5's here will go to, that'll cancel out to 0. We'll have left with an x in the numerator, and so this x's will cancel out, and then we'll just be we will end up with this guy right here, 1 over the square root of x plus 5 plus the square root of 5, and then we do the direct substitution, plugging 0 in, and we end up with 1 over 2 times the square root of 5. Woo! I had to hurry up. I didn't have much time left. Okay, and you can get this radical out of the bottom if you want, but I'm going to leave it just like that. So that should be our final answer on that one. Alright, this is going to be a similar one as the last one. We've got the limit as x approaches 0 of the square root of 3 plus x minus the square root of 3, and that's going to all be over x. So once again, we do the direct substitution, plugging 0 directly in, and you see that we end up with a 3 plus 0, so that's just going to be a square root of 3 minus square root of 3, so we get 0, and then 0 in the denominator, so 0 over 0. So we need to try to do something. And in this particular case, we are going to multiply the numerator and the denominator by what the conjugate of the numerator here. So I'm going to write 3 plus x minus the square root of 3 put that in parentheses, and its conjugate is 3 plus x plus the square root of 3, and it's all over x times the square root of 3 plus x plus the square root of 3. Okay, so we want to multiply this stuff out up here. So the square root of 3 plus x times the square root of 3 plus x is just 3 plus x. But first, I guess I need to do this. So we have 3 plus x after multiplying the first two terms. If I were to multiply the first term and the last term, you would get 3, the square root of 3 times the square root of 3 plus x. But then if I were to multiply it negative square root of 3 times, right, square root of 3 plus x, those are just going to cancel out because one's positive, one's minus, and they'll cancel out, right? So it's really just the first terms and the last terms here. So minus the square root of 3 times the positive of square root of 3, and the square root of 3 times square root of 3 is just 3. And so we're left with minus 3, okay, over x times 3 plus x plus the square root of 3. So now we need to simplify this down. So we have 3 minus 3, so that's 0. We have an x in the numerator, an x in the denominator, so these x's are going to cancel out, and we're just going to be left with the limit as x approaches 0 of 1 over the square root of 3 plus x plus the square root of 3. So now we do the direct substitution, plugging 0 directly in. So if I were to plug 0 in for x here, we'd end up with the square root of 3 plus 0, so that's just the square root of 3. Plus the square root of 3. But you see, we can simplify this down. These terms are both the same, and there's 2 of them. So that's just 2 times the square root of 3. Alright, so our original limit is equal to 1 over 2 times the square root of 3. Okay. Trying to figure out what we needed to do next here. We got the limit as x approaches 4. Okay. Square root of x plus 5 minus 3 over x minus 4. So we take 4, we do the direct substitution, plug it in. So we have 4 plus 5 is 9, and the square root of 9 is 3, so we get 3 minus 3. So once again we get 0 in the numerator. Plugging 4 in the denominator, we also get 0. So what we're going to do, just like we did in the last problem, we're going to multiply the numerator by its conjugate. So we have x plus 5 minus 3 because we have a minus, we're going to put a plus here. And that's going to be all over x minus 4 times the square root of x plus 5 plus 3. So as you can see, we do in the numerator, we got to do in the denominator. So we multiply the numerator out, right? And we are left with, okay, we need to always rewrite this. So we're going to be left with, we got the square root of x plus 5 times square root of x plus 5, so that's just going to be left with x plus 5. And then because this is a plus, this is a minus, and everything else is the same, that middle stuff, when we multiply it out, is going to cancel out. So we're just going to be left with, let's see, negative 3 times positive 3 gives us a negative 9 over, okay, I'm just rewriting the denominator. Alright, so we need to simplify things down here. Now, what we've got in the numerator here is we have, when we simplify this down, we're going to end up with an x minus 4. Now you notice we have an x minus 4 in the denominator also. So this stuff is equal to x minus 4. So we can say that this is going to cancel out. And then we're going to rewrite it. And so we're going to be left with 1 over the square root of x plus 5 plus 3. And now we can just do the direct substitution, plugging 4 directly in, and we get 1 over the square root of 4 plus 5 plus 3, and that's going to all simplify down to 1 over 6. And so we can say that our original limit is equal to 1/6.